Welcome, everybody. Steve Bogart, playing host today for this ETC session continuing on AV over IP and web series. Today we've got NETGEAR, and they're going to talk a little bit about AV solutions and network switching that's available from NETGEAR. I have Alex Pendleton, who's going to be running the show. If you have questions, feel free to put them in chat. This is an open forum. It will be recorded, so the friends and neighbors that miss this, feel free to forward them the recording. With that, Alex, take it away.
All right, and we also have Rob Hakes, who's going to be joining, and I'll introduce myself first, and then I'll let Rob take it from there. Hopefully, everybody can hear me okay. My name is Alex Pendleton. I've been with NETGEAR for about 15 years. I manage the ProAV Design SE team in North America. We're a global team that take inbound contacts for designs, for pre-sales requests, for manufacturer requests, liaison between engineering and the manufacturers out there in the AV industry, as well as support issues that potentially could happen out there in the networks that we're part of. This is a training that we actually do called Switching for AV over IP. It's an evolution to AV over IP networks, because essentially NETGEAR has enhanced the way AV over IP can be done and made an ease of use platform to quickly deploy these systems with the various technologies and the creative technologies that can be added to these types of systems. And so that's what we're going to talk about today. We're going to talk a little bit about a history of NETGEAR, how we got there, and then go into kind of some AV over IP basics and things that would need to be taken into account when we look at those systems. So Rob, if you're there, I think
I
you're
am
there.
here.
All
Yes,
right. So
I'm
if you
Rob
want,
Hakes.
go
I'm
ahead.
located in Illinois. I am with NETGEAR, manage the Midwest. And the first thing I want to talk about, it's kind of important, is the timeline, because NETGEAR is a switch company, but the NETGEAR AV team was born in AV. And in 2015, we had the 4K AV over IP chip with low latency. And then after that, go ahead. We had our first 10 gig switch in February of 2016, introduced to the industry. This is important. We were part of the SDVOE. We joined this alliance, and we were part with several other manufacturers, and we helped promote AV over IP in the industry. And this was the first group that started that to help get that moving. 2019, we have IMGMP Plus. This is one of our features that sets us apart from the competition. And Alex will talk about it, I think, in the later in the slide a little bit in detail. In 2019, we introduced the M4500 series, our 100 gig solution. This is a cool one. September 2020 is our 1 gig M4250 series. This is our most popular switch to date. This one tackles most of your AV projects out there.
And it was also built literally and designed with the feedback from system integrators. This was the first time that NETGEAR ever brought a group of people in December of 2019, the kind of who's who of AV over IP engineers, manufacturers, integrators. We brought them together and had a council, and they explained to us what the needs were for the industry. So this switch series was literally built for the integrator based on their feedback.
This was cool. In January 2021, we were certified by QSC. And one other big certification that's not shown here is we were certified by Crestron was that 2020, Alex?
Yeah, it would have been January 2020.
And that's big to us. We're neutral. We work with most AV companies out there, but it's kind of cool to see some of the big names give you that certification and partner with them.
I could take this one, Rob. Essentially, when we created our AV UI interface for our M4250s, we actually ran into scenarios where we were getting inundated with people like, hey, you guys left a profile out. What about lighting? What about lighting? But it took us a little while. We had to get the lights into the lab, and then we had to test the different systems. But then we came out with our lighting profile in February 2022. And to give you an example, the lighting profile that we utilized was actually used at the last two Super Bowls for the halftime show. All of the lights that you saw were running over NETGEAR infrastructure.
2022 is NETGEAR Engage. That's our free software we use to control everything, and we'll do a little bit of a show and tell on that later in the slide too. July 23, the M4350 series. That was introduced, and that's the second most popular line today for AV projects. And then 2024, we've got 2 switches that are SMPTE certified, and this is a direction we're moving forward. You'll see us more involved in the broadcast area.
Yep. So in 2025, we are building switches and infrastructure right now that will be focused more on the live production space. So live production has specific needs, and we're aware of those. So we're working on creating systems specifically for them.
We like to take time and just go through the timeline. I know probably not important to you guys, but it just shows how we're involved in the AV industry and where we came from and how we got to this place. I lost my driver. So we've got...
Yeah, I'm back. All
sorry.
right, sorry. Had an alarm going off, had to turn it off. It was in my ear the whole time. So go ahead.
Cool. This is a list of our main partners. This is almost the who's who in the AV industry. And becoming a partner with NETGEAR is more than just a checkbox. We send gear to that manufacturer. They send us gear. Our engineers are baking it, testing it on the network, trying to solve problems before you realize I'm in the field. So when you see someone as a partner with a NETGEAR, it's not just a checklist. It's an actual exchange of gear and really certifying that everything works and goes smooth.
And honestly, this is a tough thing to do, and we will not. I will tell you. I'll confirm to you right now. We will not cover every corner case. You know, even with all of our partnerships, the one thing about the AV over IP industry, as you see all of these partners on this list, is it's growing. This is as the most latest list as of March 26, 2025, but there have been 17 new. As of the beginning of April, when we went to NAB, new customers, new AV over IP manufacturers that we actually worked with at NAB and found out that they were not on the partner list. So we added them just as that event took place. So with this being a growing list, we'll always find scenarios that we didn't see or that we didn't anticipate or that the integrator's creativity created. So we always want to make sure that we continue to work with our partners as closely as possible. And we're very, very honored to be the centralized focus for all of these different AV signals that they can create.
I like to tell a little funny story here. We'll go back 1 second.
Oh, yeah, sure.
When I started with NETGEAR, I was at another manufacturer and I was doing training classes for education. And I called NETGEAR because I was recommending NETGEAR switches for AV over IP projects because it made them go that much smoother and that much quicker. So I called for some demo gear so I could run my training class. And that led to me becoming a part of the NETGEAR team versus getting the demo gear. But I'm still waiting for that demo gear today.
Yeah, we'll get it. Checks in the mail, you know. But with all those manufacturers, so sometimes there's going to be scenarios where our profiles, our default profiles, don't exactly cut it. And so we will need to build into our system a configuration that supports those systems. As with Alan and Heath's Giga Ace controllers, the way they like to see work on the network and like to see other endpoints and just be discovered by other endpoints, all of those things need to be configured into the network. Bluestream multicast systems, Lightware AV. So these are just to name a few. We've done a great job with the Crestron Digital Media AV network that has literally solidified that entire network at small and at scale of enterprise capable networks. And then, of course, Visionary AV network, which is continually being added. We're adding all the time, but we're going to also improve the ones that we have. So with that being the case, this is always something that we'll continue to evaluate and grow forth. So to cover over the main lines one more time. So you have 13 switches in the M4250s. The maximum uplinks are 10 gigabit. So you can create a 1 gigabit audio over AP, or you could do a video over AP with a 10 gigabit network backplane. The M4300s were our first IT switches that were kind of converted to AV, but they were built with IT in mind. They also had some scenarios that didn't necessarily help AV installations. So moving on from them to the M4350s was a logical progression. And that's what you have in the M4350s. You have now 100 gig uplinks rather than 40 in the M4300s, bigger core status, plus Grandmaster and boundary clock capable switches in that field for our SMPTE 2110 and broadcast partners. And then you have an M4500, which is our aggregator core that can bring all those M4350 100 gig links together in a software like protection for precision time protocol and other things. So that's our complete offering to the AV over IP. And these are the approved switches for the AV over IP installations.
And where you're going to see our growth is that 4350 line, where we're going to
Mhm.
continue to expand and build out, and you're going to see more SMPTE 210, I assume, in the future.
Yeah.
We do have TAA compliant switches now. This is a government mandate where the switch is manufactured. I can send everybody a cheat sheet if you want to reach out after that lists all the switches, and then it also highlights our TAA versions as well. So if this is important to anybody on certain projects, we do have them available and they are shipping.
Okay, so I'll cover some of our key features. We talked about a little bit, but the AV user interface that has each switch has a web interface that is the AV UI interface that you can log into and create customized profiles and templates utilizing that AV operating system. We're going to look at Engage today. I don't necessarily have my lab into a demo, but I'm going to do my best to see if I can get it organized into a demo as quickly as possible. But we'll go through Engage. We'll go through some of the features and why it's a great solution for the medium, large, and enterprise level AV over IP networks. Also, we have into Engage, we can onboard our PR460X router, which is this system right here. It's a Pro router, standards based, 10 gigabit LAN to WAN, dual WAN, very, very capable system. Also has 1 and 2.5 gig multi-gig ports for communication. And we also have 2 Wi-Fi access points that can also be onboarded into Engage. Where we see Wi-Fi and AV over IP is not necessarily to send like video or audio signals, although in some cases you can do that. We do see a lot of it in control. So touchpads, touch panels, iPads, anything that can be utilized to manage the AV system could be utilized in a Wi-Fi infrastructure. So that can be onboarded to get Engage and then also managed that way.
That Pro router that we were showing, that's very popular in education. I have a lot of end users that like that to separate, have a firewall from that IT department network to the AV network. And that's a simple solution to kind of draw that line in the sand. And it's an inexpensive solution.
Yes, yeah, it's a like I say, standards-based firewall does a very good job to round out the solution. So the big unique feature that we came up with in 2019, which was a way to organize communication for AV over IP. And the reason we call this training the evolution of AV over IP is because once NETGEAR started to look into this industry, we found that at layer 2, we were not able to build larger and larger networks to do more and more things. And as time progressed, we found that if we were to make some small tweaks and changes to the way IGMP behaves in a multi-switch environment, that it would allow for that layer 2 topology to continue to scale, then you would not need to move to a more complicated configuration like layer 3 IP PIM routing, which was the old way of managing large scale AV over IP networks, which would be a frustration to the system integrators in a lot of ways. We listened to them explain how hard it was to get layer 3 PIM working. You really needed to be a network engineer to understand what was happening. A lot of AV integrators didn't want to do that, but they want to understand the basics enough to get a layer 2 topology set up at scale. And so I've kind of coined the enterprise network as being any switch 30 and more. 30 network AV over IP switches in a network would be considered an enterprise scale AV over IP network, which is different than the IT scale. And IGMP Plus allows for these types of networks to behave appropriately, allows them to be very dynamic and fluid, and it allows the integrators to be very creative in how they build this AV experience for their customers. And that's a big differentiator between NETGEAR and its competitors. How we found it was simply a, we started working on a network at Cooley Law Firm. They had a few floors that they were sending large bandwidth back to the core switch. In this case, I'm showing it as a spine switch or courier. And all that communication from the transmitters was flooding back to the spine switch. And so when we added IGMP Plus into this network, it smart handled the transmission communication so it didn't flood up to the spine switch. And only when a subscriber somewhere else in the network was looking for a stream of AV over IP, and at that point, we would allow that transmission to flood back to the spine switch and out to the edge switches. And it became a single, as soon as we placed the firmware, it just absolutely resolved and allowed this dynamic experience, and was quite the experience for the integrator who had been fighting with this issue of erroneous flooding for quite some time. So we were able to achieve that with IGMP Plus. Out of the box, our switches will, if you connect them together, trunk those VLANs and the different AV profiles that you have connected on each switch across that link to make sure that they're maintained as they communicate. So this allows you to create a video profile or audio profile or lighting profile, and you can connect the different endpoints that do the different things into their own domains, and then it'll be preserved switch to switch so that you don't have to do any out of the box configuration. Or any configuration except out of the box. And then for multiple links between switches, we'll build a new interface automatically for you to, one, linearly increase your bandwidth, but also give you a level of redundancy as well that allows you to get more from the switch to switch interaction. And we do this all automatically out of the box. It's set to be configured for you. So back with the illustration of the flooding that we saw on the left, you have your IGMP Plus enhancement, all transmitters flooding back to the spine switch, literally saturating those uplinks and not allowing any of the broadcast or control communication or any of the other communication that needs to be sent across the network to reach it. And then once you have IGMP Plus, a nice even communication, tightening up the methodology to send signals across the network. Okay, so we're going to jump into a little bit of networking basics. I don't have any swag to hand out. I had some questions, but I'm just going to answer them and then keep on rolling. But if you do have any questions, please ping us and we'll address them towards the end. But let's get right into it.
You can ask questions. I'll send swag out if you want.
All right, cool.
I'll make sure they get it.
So the question is, what is a VLAN? And this is actually a question that I ask to my on-site trainees when I do this training. It's kind of a fun one because I ask them what a VLAN is, and they always come back, virtual local area network, which is the 100% right answer. But I actually tell them it's wrong because a NETGEAR AV profile is also a VLAN. They're synonymous. When you're creating a NETGEAR AV profile, you're also creating a VLAN. So it's kind of a little trick question to kind of illustrate what our profiles actually are doing. The reason you have VLANs is because essentially when the first annals of the internet, they had, USC connecting University of Utah, you had University of Washington connecting back to University of Utah. They were first testing all of this traffic that they could send between each other. All that traffic was just condensed into the same pipes and not really discriminated against on what traffic needed to go where. It was just all kind of going in the front door. And so they decided to create a system that would essentially isolate the traffic into buckets. And so let's go ahead and carve this switch up into the different AV buckets that we'll have. And we'll do car traffic, equestrian traffic, bike traffic, and pedestrian traffic. All need to have their lanes on the freeway and all need to have the ways that they can get to their locations, but they don't want to interfere with each other anyway. This is how VLANs essentially are set up in this. And the way it works, if you're following the mouse here, we'll take my AES 67 network. As soon as this red dotted packet comes into this port, the switch will ask it a question. It'll say, hey, are you tagged? And of course, if it's an endpoint, the likelihood of the traffic being tagged is very low because most endpoints don't support a VLAN tag of information. And so at that point, the packet will come in, the switch will ask if it's tagged. If it says no, it'll go ahead and add a tag into the header of the packet. We open up a little space, we put the VLAN ID, in this case 30, and we put it in the header of the track in the packet, and then it processes the packet to the location that is it's supposed to go. We'll say it's this port here. Once it goes out that port, the switch, if this port is an untagged switch port or member of this VLAN, it will remove that VLAN addition that we added to the packet and forward it on to the endpoint. The reason we want to remove the VLAN information is because the endpoint most likely doesn't understand VLAN tagging. And so we would need to remove the VLAN information from the tag, because if it were to receive that packet and it had the VLAN information added to the packet, the header size would be larger than that network interface card supports. And so it will drop that traffic. So it's very important to know which devices can support tagging and which ones don't. Typically tagging, similar to our auto trunk capability, you want to tag to preserve from hop to hop or switch to switch the communication. And that's what tagging would do. If you were to tag this interface, you would plug it into another switch and you would preserve the VLAN information onto the next hop. So once the packet came into the next switch, as it comes into the port, it'll see, oh, this has a VLAN tag of 30, send it to the device that it's trying to go to within the VLAN 30. More importantly, as I'm sending into my VLAN 30 domain, I'm not sending to the ports that are in the VLAN 20 or 40 domain or the VLAN 1 domain. And this allows for the separation and segregation of the traffic to maintain its communication while not interfering, even though it's all on the same switch layer. NETGEAR made a decision, I think back in 2007, that all of our fully layer 3 managed switches would have a default configuration out of the box. This was VLAN 1. So all ports right out of the gate are connected in VLAN 1, and they are all online and up so that you can get working right away. We added that to the AV system by adding what I call the partial video profile. It does not have any of the audio prioritization, but it will have multicast, IGMP, and stuff like that to prove, and IGMP Plus to be able to go ahead and start working right away. And it has a very good plug and play scenario in smaller AV over IP networks. Okay, so what is unicast? What is broadcast? And what is multicast? Well, when you're in unicast, it's a unique communication one-to-one to an endpoint. In broadcast, you're sending to everyone simultaneously, and you will do this utilizing various broadcast addresses. Whereas in unicast, I'm calling Rob directly on his phone, and I will get Rob on the phone directly, but nobody else can hear our phone call. Well, hopefully the NSA is out there, but you know what I mean. And I'm calling him directly. He hears me and I hear him, but nobody else is in part of that conversation. In the broadcast, everyone receives the broadcast in a network, and they get all of those communications that are being sent out either with a destination of all 255s or within the subnetwork of the last octet being 255 in the large. With multicast, this is a selective method, essentially treated as a broadcast without a management system to manage it. So multicast is required to send. I mean, it still does what one to all, but it's selected based off of IGMP and multicast routing, and that's why it's a little bit different than, say, a broadcast. Is only select devices that request the group information from the source will receive that message, and the ports that do not request that will not receive those messages. So that kind of makes it great for AV over IP, because if we were to take a unicast communication for AV over IP, say I were to take purple and I wanted to see what was happening on red. Well, if I were to take purple, change it over to red, if I'm a unicast, I have a unique stream, which means I will pick up this stream at the beginning of that stream as a new connection, not an existing connection. So that, in a sense, is not efficient for IGMP, especially if you want to create a dynamic changing environment where, say, a professor would like to see what that student wants to see on the main, and they grab that stream that's coming into that HDMI and they want to flow it onto on the board behind the professor. They would not be able to do that in a unicast environment. Well, let's take broadcast, for instance. Why don't we just broadcast to everything? Well, if you're broadcasting video to all ports, that's going to be a congestion that you don't want to see. But not only that, most all broadcast actually has a unicast response, meaning I broadcast out looking for something, but once I find that element, that device doesn't broadcast back. It sends a unicast response usually to my thing. And I say usually because DHCP is an element where you could have multiple broadcast communications, even though you received a unicast in response. So enter multicast. Now, the fun thing I would suggest is if you have an encoder from like QSC or Crestron or something like that, and you configure it for AV over IP, go ahead and take your laptop and connect to it and see the little UDP containers coming to your computer of multicast. The encoder, just as a basic rule, start forwarding into the network. The network does a good job of holding that at bay until a subscriber comes along and says, I would like to listen to said stream. That subscriber sends in a communication to the switch. The switch goes ahead and builds a route between the source and the destination, and voila, you have a stream in multicast. Now, say I wanted to take this exact stream and I wanted to change it over to this device here. This device will pick that stream up right in time, right as it's happening, coming into the network dynamically, which makes it beautiful for multicast or for AV over IP. Multicast becomes really the dynamic experience that these integrators and customers are looking for, to be able to switch the boardroom TV to a direct TV set-top box down on the 9th floor that's receiving the direct TV coming from the satellite on the roof, to be able to pull that into the boardroom once the meeting's over so they can watch what's going on the television, or bring up some kind of stream from an outside source into that boardroom for a presentation. All of these things can be done very easily with a multicast AV over IP network. But you do need some things. As we talked about it, you need some settings. You need some things to be installed on the network. So let's take our stream. Let's go ahead and say we have our media server streaming to our endpoints. Everything looks fine. I do need IGMP configured. Now we have IGMP plus, but in general, you need an IGMP filter to be able to look for, we call it IGMP snooping. We need to look for those subscribers. We also need to look for those sources that want to stream to those subscribers. And that's what IGMP snooping will do. Once it finds those devices, then it will send it over to the courier and say, hey, I have a stream that's going to be built, and the processor of that switch will build a route between the sources and destinations within that broadcast domain at layer 2. Then, to keep the streams moving, every so often, 60 seconds by default on NETGEAR switches, the switch will send out a query request. And that query is to ask who's still listening to multicast. So it sends out a burst, hey, you who's still listening? The devices will reply, I'm still listening to this multicast, back to the courier. And there's a 600-second timeout by default on NETGEAR that will tick down until the query message is received by the endpoint. Then it'll bounce back up to 600 seconds and tick back down again. And this happens to keep everything streaming so that the switch knows that this port is still receiving that stream and still listening to that multicast group. So the question that we usually add to this, which is an important feature because many times our IGMP Plus enhancement gets confused at this, and I like to explain this in a detailed way. If I would want to send this media server stream here, and I want to send it over to VLAN 2 at layer 2, and I have these devices streaming fine, and I'm like, okay, I now have my 3 new stream devices that are going to be listening to this media server in VLAN 2. What do I need to configure? Well, I have IGMP enabled because I'm streaming in one VLAN, but the minute I try to send to VLAN 2, it fails. And I'm not sure how that happened. Like what's going on? What more do I need to configure? Well, you can't continue to stay at the layer 2 domain in a multi-broadcast domain environment. Our IGMP Plus enhancement doesn't help you do this process. There's another part of the multicast standard that we would have to configure, and that is layer 3 IP PIM infrastructure, which adds complexity. It kind of adds some frustration because it has to be configured perfectly. Routing has to be configured perfectly, and you have to have a rendezvous point that needs to be configured in between the two VLAN domains. That's why IGMP Plus is created. I would simply create these 3 endpoints, but I would put them back into VLAN 1 with the media server, and I'll none the wiser. I would not saturate any uplinks or have to go this between VLAN to VLAN configuration. Okay, so how do we elect a courier and what do we expect from the courier? Well, there can be only one. It's kind of like the Highlander. There must only be one courier in a VLAN. You could have multiple couriers, but that might be a little bit chaotic because the streams would not necessarily receive correct information from the courier, and the wrong courier might get updated versus the other courier, and the stream may stop. So you want one courier in a multi-switch or single switch environment, and the lowest IP address will win the election. So the spine switch is what we prefer. So if you have a multi-switch environment, try to use the star or spine and leaf configuration and leverage the lowest IP address for that switch in the VLAN that you're in. That will win the election process for the courier. And then the backup couriers will be on these other devices. Say this device for some reason goes offline. This device here, 192.168.1.2, will actually take up the query duties while we resolve the scenario with this device. So having a courier just be the elected lowest IP address is really the best methodology for leveraging the courier. Okay, so now let's go ahead and move on to understanding what a multicast address is, what it looks like, how it works. When you think of multicasting, the way that they originally created the RFC in the back days, essentially you could look at it like they were thinking of your car subscribing to a radio station. You might want to listen to a radio station. They're like, hey, I want to change that radio station to be something else. And then suddenly you will have a radio frequency multicast address similarity. Even though I'm on the freeway with other cars, I subscribe to a radio station, but I'm receiving that radio station. The other device, the other cars that are on there with me aren't necessarily listening to it. Similar to multicast, when I subscribe to a multicast, I get that address sent to me. The ports I'm next to do not get that unless they also subscribe to that same multicast address. So the multicast address space is a Class D space. It's considered the Class D space. There's no subnetting. Every single IP address represents a specific group. Now, we do have sub ranges, which we consider to be kind of an off limits location to do AV over IP. And many of the manufacturers we've worked with have followed suit in this same pursuit. 224.0.0 anything is what we call the local control block. And we typically like to stay out of that communication as best we can. We try to not have a scenario where we have communication because a lot of the switch technologies, routing and different things, different advertisements take place in there. The query message, for example, that comes from the switch to the endpoints is on 224.0.0.1. The source-specific multicast block is a block of multicast addresses that are typically used in IGMP v3 or IPTV environments, hence the source-specific icon. Essentially, they are leveraged there, but that doesn't necessarily mean they can't be used for AV over IP, as they are used in IPTV and broadcast networks, but we typically see those types of systems utilizing that block. And 239 is a global organizational local scope or admin scope. It's been kind of, anything goes in that one. You can put discovery in there. You could put whatever you want. The key would be to change the center 2 octets to be something. So your first octet be between 224 and 239, encompassing the 228 million possible addresses, but then change that center octet there, number 2, to be something like an 8 or a 9. In Crestron world, they do 239.8, and then they increment the third octet by 1, 2, 3, 4, and then they change the fourth octet to be whatever they want. And this allows for the switch to process very quickly because the switches speak MAC address. And so when you're looking at the multicast IP, it can be converted to a multicast MAC address, and it has a start OUI of 01005E. That's how the switch immediately knows that this IP is a multicast address. It looks at the multicast MAC address, as switches speak primarily the MAC address. When you change the center to octets, these 4 digits, also change to be something unique within hexadecimal, and the fourth octet obviously being changed as well when you change out the fourth octet of the IP address. So this will be determined as the stream address according to the switch. But if we go ahead and convert the actual multicast IP to the multicast MAC, you can see that it also has different relationships. If you configured a stream 230.0.0.1, you would technically be sending the stream to the exact MAC address as the courier. So having this kind of philosophy of modifying your streams to modify the center to octets 2 and 3 helps with the stream health and identity and isolation from other possible streams in the network. And most manufacturers have caught on to this, and they've made those changes similar to what Crestron did with 239.8. So let's talk about the differences between, we mentioned IGMP v3, but let's talk about v1, v2, v3, kind of how they got there. So you can look at V1 as a way to communicate to an industrial group of machines, essentially like a whole group of machines are processing a big conveyor belt of some process, but you want to communicate to some machines, but not all machines. So you don't want to broadcast to everyone. And these machines, you could call them dumb machines because they just receive commands and receive updates. Multicast V1 would be great for that because those devices could be connected to a network. They'll subscribe to it. They'll respond to the query, but they're not going to leave the multicast group they're subscribed to, and you can have multiple machines updated simultaneously. IGMP v2 is similar to IGMP v1 and backward compatible to the courier of the IGMP v1 as well. But in this case, they added an element that if a device wanted to leave a multicast group, it could send a leave packet to the switch, and the switch will process that leave. Now, switch manufacturers picked up on this and created an easy way to move the multicast group faster by receiving a new membership report from the endpoint and processing a leave at the same time. That means if I was an endpoint listening to a multicast group and I want to listen to a new multicast group, which is a new stream to show a new display or hear a different audio, as soon as I receive the request from the control system to change my group, I send to the switch a new membership report, and that processes a system called fast leave on NETGEAR switches, which gives you that dynamic nature of modifying your AV over IP experience. So most systems are in IGMP v2 configuration. IGMP v3, all of the same things, backward compatible with the courier, also has the capability of the v2 to leave, but now adds a specific scenario of the source information in the join packet being filled out, saying, I would like to listen to this multicast group, but I would like it to be from this source. And that is the huge difference between V3 and V2. The switch now needs to build a table with a V3 IGMP packet and say, this is the stream for this source, or this is the source of this stream, and build it into a table that can be parsed when we receive the joins from IGMP v3. NETGEAR is fully compatible with all three of these configurations. So, a large conversation that we have, this is kind of a silly slide, I'll move this over here. Essentially, we do have scenarios out there where the AV integrator will go head to head with the IT guy on staff about the AV switch infrastructure that they want to deploy. And we have some ideas on how to help with that. First of all, you can bring me and my team in. It's a great discussion that we can have with the IT team. We are all IT focused engineers for many years, and we've been adopted into the AV over IP world and focus our efforts there. But we can have the discussions and eliminate the concerns of the network admins on premise in many ways. The other item is a connection to their network, which is really critical. Any type of conversation with them is how do they want to connect to the network? What do they expect by connecting to the network? And what do they plan to do with that connection to the network? The next item is, do they want to manage the AV over IP VLANs from the IT infrastructure? With this being the case or the question, you typically want to find out what the goal would be, but you can also set this up utilizing static routing, and it requires their support and help to set this up, but we're fully compatible with that. And of course, we can always help with the configuration at the ProAV design team. Do they require access lists for security? Typically, most IT personnel love access lists because they can limit and prevent traffic from going to different places. And from one place to another, if you're connecting an AV network to an IT infrastructure, access lists may be requested. Just know that we have fully layer 3 managed switches that are certified for AV over IP that have the capability of producing such access lists. Network access control. When we did NYU a few years ago, NYU came to us and we heard through several telephone effects that, they did not want to add a new network infrastructure to their current infrastructure that supported network access control. Well, once we all got into a call, and we were able to discuss with their director of IT, they had a unique method of control that they were setting up that required network access control identifiers added to the systems that were going to be connecting to the Wi-Fi infrastructure. And so that was their plan with the control interface. Of course, NETGEAR does not support network access control. We do not, that's a proprietary technology to our competitors. And so what do we do? Well, we offered to put a router in between the AV network and their network, and they subsequently gave us a public IP address that we could route between in their infrastructure and the AV infrastructure, and so their control could communicate to and from the AV network. And that is a solutions-oriented approach at a problem that we were able to work around. This should not necessarily be something you ask a network admin. This should be something that you explain that you can do to a network admin. And also, I also go a step further with the philosophy of this, but you should be blocking any multicast requests on any uplink that's not a part of the AV experience. If it's a converged network with an IT LAN as a backbone for internet or for other reasons, blocking multicast on the uplink should be a priority, and we have a very easy way to do this in the AV UI. The other item is spanning tree details for the configuration. Spanning tree essentially is and has been a core fundamental of NETGEAR's configuration. When we were at the Super Bowl, we had 4 different networks plugged into us, and we could not participate in the other trees as we would appropriately also not want them to be participating in our tree. So last but not least, your spanning tree details of the configuration is really, really important and critical. And you should approach this with the network admin, explaining that you can either disable spanning tree entirely on the link going out to them, or you can block any of the communication coming in from spanning trees so that no one's trees are participating together. Okay, so I'm going to move on into PTP and get into a little bit of the specifics about precision time protocol, what it's used for, what its purpose is, and where we see it mostly. First, it should be explained that 2 types of PTP exist, V1 and V2. That sounds like a progressed version. It is kind of in a way, but it's not backward compatible. And so it really is a complete different enchilada. PTP V1 has its own offsets. The switch does not need to participate in that. The larger the size and the more switches you have, the more distance between the grandmaster and the endpoint is up to you to adjust those offsets. In PTPv2 land, we do have a system that we can interact with now, and we can update the PTP packet as it comes in and out of the network switch. We call this end-to-end transparent mode or transparent clock mode, and this is capable on all of our current switches that we offer for AV over IP. To follow how this PTPv2 end-to-end process works is you take a packet of information, it goes to the PHY, which is just behind the port. So coming into a port on the switch, you go to the PHY, which is just a little coalescer of packets before it goes and gets parsed by the main controller, which is the MAC. And as that packet moves past the PHY, we begin tracking its time. And this diagram shows two MACs, but that's not true. It's still the same chip. And as it leaves that chip and goes out the next port PHY, we stamp it and update it in the correction field with how long that packet spent in nanoseconds within the switch. This allows the grandmaster and the follower clocks to understand the communication of that packet happened through a medium. And it gives a better sync and a more dialed in communication between the grandmasters and the follower clocks alike. Two of our switches, as we mentioned earlier, have the capability of being a grandmaster or boundary. The big difference between grandmaster is the grandmaster is the main sync clock for the network. A boundary has a sync to follower clocks and ordinary clocks, but also has a reference clock somewhere else in the network. Our M4350 16V4C, that means it has 16 25 gig fiber ports, SFP28. And then it has 4 100 gig QSFP28 uplinks. Then we have the 40X4C and 4350, which does 40 10 gig PoE++ ports and 4 100 gig QSFP28 uplinks. Great for aggregating to an M4500 or larger network, or being out on the edge in a larger SMPTE ST2110 design. Okay, so let's cover PoE and PoE Plus and PoE Plus Plus for our Power over Ethernet systems, because PoE is such an important part and offering for AV over IP. It prevents you from having to run power cables everywhere and having, different systems linked all together with power cables. It really is a benefit to the industry. There's these 4 types, essentially. One type, or type 1, is 802.3AF. It's the early PoE. It supports 0, 1, 2, and 3 classes, and all of them connect at 15.4 watts maximum per the port, which actual sent energy is 12.95 watts at a distance of copper, which is the 100-meter distance. We also have PoE Plus, which is the 802.3AT type. And the reason these types are important is because as soon as we detect what type it is, then we can learn more about the juice that device is going to learn, such as its class. And then we have PoE++, which is the newer standard, the BT standard, which I don't think we're going to be going too much farther past the 90-watt type 4 or the 60-watt type 3 in AV over IP. At least we do see some systems coming online that utilize it. There's a few Crestron and QSC systems that use it, and most likely we'll see speaker systems in the future start to leverage that higher power output. Excuse the death by PowerPoint on this one, but I hope it will illustrate how we do that. As I mentioned, the types are how we discover the devices, and then we give them just enough power to boot so that they can send us a complex packet like LLDP, which is discovery layer protocol. Once we receive that LLDP packet, inside that packet is I am this device and I can do power at this class. And at that point, we open up the type of class capable for that device, and it pulls the juice from the switch that it requires, and we archive that into a table. So you can see the different types. 0 and 1 are the same. They go up from 0.44 up to 4 watts. 2 is around 7 watts. A lot of devices, cameras, speakers, different things, different peripherals are in there. 3, you'll see a lot of access points. the NDI cameras that can move around just on the fly. Those are always in there. You also see some in the PoE plus 30 watts, a lot of things in the 30 watts, and all of these types and all of these classes are backward compatible. So if it's a PoE device, it can totally work on a PoE plus or PoE plus plus port as well. And then you see the next gen video and lighting applications, 8K systems will all be in the PoE plus plus realm of power for sure. Okay, so just to cover the triangle, remember that hardware is what we built for the AV over IP industry and the AV line, and further into the M4350 line. The M4300s are in their product sunset, so they're on their way out. Software also part of the triangle as well. And then you have me and my team, which is the support element of this. A ProAV design at netgear.com can be reached. We will send you a device if we need to. If we find a hardware problem, we will replace it with the next business day if needed. And then, of course, you have me and my team for the duration. To go further on my team, so this is Laurent Tamazia. He's the product line manager for all of our switches, and kind of the godfather at AV at Netgear. Myself and Derek came to this team at the very early days to try to help facilitate a lot of the growth that we were experiencing, so that we could help the integrators out there develop these networks. Andreas in Germany, Eric Lindemann out there in Benelux and Netherlands area, Hideaki in Japan, extremely important to our broadcast relationship with Panasonic. Holden Guo is out there in China. You have Guillaume Oliver also with Laurent in France. You have Kieran Purdy out in the UK, Neil Smart also with him out in the UK, and then Manab Malik in India, and Samuel Tan in our Singapore office. And then I'll introduce you to the A team, as I call it, the team here in the United States. We have Michael Deck, who has now moved from Ireland to the United States to support this team, as we are growing faster than any other market. And Laurent Gormazano, also in Ireland, supporting Kieran and the EMEA team. And then we have Stefan Tabliso on my team, and Nicole Lewis, who also does a lot of these trainings. Casey Hawk, who handles a lot of our enterprise level 30 and larger switches, and then Ryan Jackson, who's a lifelong engineer that has completely came to the ProAV team and supported this enormous effort. If you need to find anything Netgear AV, it is at our portal by simply going to netgear.com/AV, or any of these shorthand communications for all of our switches, including our Engage software. And then we have our academy, which has this training, has other trainings that you can go into deep. We have AVL1, which is a deeper dive into our systems and networking in general. We also have, actually, it is now Academy at Netgear. So this is an old slide. It should be academy.netgear.com. But essentially, yes, you can go to that to learn for AVL2 as well. We also have a great broadcast breakdown. If you were literally to Google ProAV technical guides, you will find our AV technical help as well in that, and you'll find some helpful documents on how to configure Netgear AV switches with different protocols and systems out there. And then, of course, my team, ProAV Design and Netgear.com, and then we have our Pro Wi-Fi design team to support any kind of Wi-Fi concerns or design help that could be implemented. They have a way to do a remote site survey. You can give them building information, and then they can create a way to plug in those AV endpoints or AP endpoints to get Wi-Fi coverage, maximum Wi-Fi. Of course, we have a community as well out there. We also have a Facebook group out there for our Netgear AV switches, the M4250. That is quite active. Okay, for participating in this, if you are CTS certified, you can go ahead and utilize this AV over IP link here. It should take you to our website so that you can get your 1.5 CTS renewal credits.
While you guys are doing that, I'm going to mention, this is Rob. We are really turning our focus to the higher education market this year. We have a class rolling out in every state every month in 2025. So if that's something you'd like to participate in, feel free to reach out to me. Most of those schools allow you guys to attend. Or if it's something you think about hosting, where we do a class similar to this, but hands-on with the gear and run through the setup, reach out to me as well. And we can talk about maybe coming to your campus, in hosting one of those training classes. It's free. It's 6RU, Alex?
Yes.
Yep. And so higher education is really in our focus this year, and we'd love to have you guys participate in something like that.
Great.
All right.
Let's open it up to questions. Any
Cool.
questions from the group, or if you are too shy, we will start calling on you. No, just kidding.
There are prizes for a question.
I'll start because usually it takes someone to start and then the questions roll up. Let's say you're an IT or AV director and you go to the IT department and you're saying, "Hey, I want to bring in these NETGEAR switches," and they say, "No, sorry, we're a Cisco house." Is that a problem? Is it a problem to get the two different brands together?
It's not a problem to get the systems to connect together, to communicate together, but it is I would have to say if you want to call it a reputational thing. I think there's always like that statement out there on Reddit. It's like you don't get fired for speccing Cisco or something like that. There's certain things certain systems do, and there's certain systems that don't do it very well. Cisco has been the incumbent for a long time. They've been able to do AV over IP systems. They've been able to do broadcast systems. They've been able to do really, really large IT infrastructure, enterprise caliber. But the one thing that we do better is the ease of configuration and deployment. It saves you time, saves you effort, and it works with the amount of manufacturing partners that we've accumulated. If you did run into a scenario where you couldn't get the Cisco system to work, they will not answer the phone to support you.
I've experienced both of those, the ease of configuration and the impossibility of getting hold of anybody at Cisco that would talk to me.
Yeah.
So
I think that's something that's missed a lot is from the IT department's perspective. They don't have that firsthand experience. They don't get to feel that pain of the install and the hours taken of another system versus the NETGEAR. So open to ideas and how to communicate that to the IT departments at the higher education levels so they can see that pain a little bit and the time saved by using NETGEAR.
I'll add to that question a little bit. What kind of objections do you normally see? Are they concerned about multicast egress or management and inventorying of items? Do they see it as an attack vector, having ports that they don't, administer being connected to the network? Or what could somebody study up on for that conversation to help hedge some of that?
Well, essentially, so it's never been a security question because, interestingly enough, NETGEAR has one of the absolute most secure platforms. In fact, a major credit card company put us through a penetration test up against Cisco and Arista, and we won. And we were the best, most secure platform for various reasons. We have a smaller packet buffer because we're not a storage unit. We like to hand off the communication as quickly as we receive it, parse as quickly as we receive it. Those other systems, they have larger packet buffers to store data, to hold on to information. And because of that, the credit card company did not go with them for their AV over IP infrastructure. And so that's why it became a scenario that we would have a great opportunity to win in the first place. So security is always at the forefront of our processes and what we want to do. We have an enterprise caliber security system and all of the standardization out there, including more to come because we're developing even more unique infrastructure elements to allow for more security and better flow for AV over IP, because in AV over IP, security has kind of been left behind. The biggest objection that I could tell you that we have run into is standardization. So for example, University of Nebraska is standardized on Aruba. Their IT team will not allow any other switch manufacturer to come in, and they continue even though they had one really horrible outage that took place when the assistant dean was addressing the alumni for their AV over IP system when it was running on Aruba, which caused the AV team to scramble to take a system that was going somewhere else, readapt it for that system on our switches, and fix that system for that installation. And so it is a scenario of, hey, we're standardized on this switch framework, we don't necessarily want to have another switch vendor to manage. And if the AV team or the integrating team can manage the infrastructure, explain how they're going to manage the infrastructure, I think it'd be a lot easier. And then the other thing I would suggest is the terminology. When you say AV switch, people they start thinking network switch, and then they start anticipating, oh my gosh, Yale University when they switched from HP to Cisco and the whole campus went down for days. They start seeing that in their mind, right? And so calling it an AV switcher is also a good way to kind of differentiate between network switch and AV switch if you wanted to try that. Good question.
There was one in the chat that I think was answered. Somebody was just asking about videos to write along for setting up a switch. So they've got a link for that. Any supplemental that you'd add? Is there a specific track or YouTube channel or somewhere like that that's a good quick hit micro learning resource?
Oh, absolutely. There's a whole series that our he's like a VP. He's a director of marketing, John Hankel. I tease him because he has an Emmy and he lets everybody know. He does his Zoom calls. He's got his Emmy over his shoulder. It's like, oh, there's an Emmy there. He's like, oh yeah, look at that. It's kind of funny, but yeah, he did all of our videos on the AV UI. They're still relevant, although a lot of new profiles are there. Some other skin scenarios have been modified. Sorry, I got a cuckoo clock from Switzerland going off. I hope you guys don't hear that thing, but essentially, yeah, he's done a really great series on that, so you can find that there. There's lots of webinars we've published on new technologies, new profiles, broadcast elements, and yeah, we continue to produce that information and try to get those hitters out there.
The NETGEAR Academy has fresh courses too. It's not old material. I think those were just published within the last 3 months. So you're going to get some really good content out of that. 3 brand new courses within 2025.
That's great. Thank you.
I think that's at time. So thanks everybody for joining us. Tune in 3 weeks for the next installment of the web series, an AV over IP. Look for your invitations coming out shortly.
Cool. Thank you so much. Nice to meet everyone.
Cheers.
Take care. I'll see you.
Thanks, Alex. Thanks, Rob.
Thanks, guys.
Thank
Bye.
you.